Computer networks, network simulator. Now we need to implement the Ethernet LAN using 6 to 10 nodes and compare the throughput by changing the error rate and data rate. So this is the question. So we are using network scenario generator tool, that is NSG, for creating the Ethernet LAN. That means basically we need to get the TCL file to simulate using the network simulator tool, that is NS. I am using the NS tool, network simulator tool. So to get the TCL file we are using the network scenario generator tool. So first task is to create Ethernet LAN using 6 to 10 nodes. So for simplicity we are creating the Ethernet LAN which is having the 8 nodes, that is 1 2 okay, if we start from 0 1 2 3 and here so 7 6 5 and 4, so 0 1 2 3 4 5 6 7. So in this manner we are going to create the Ethernet LAN. So I'm just going to the terminal. So here something is there, so let's clear all these things, and here too let's clear. Okay, so the first thing, java.jar nsg 2.1.jar. okay, java underscore jar nsg, it is nag I wrote, nsg 2.1.jar, and here go to scenario, new wired scenario. So now we need to create the LAN with 8 nodes, 1 2 3 4 5 6 7 and 8. okay, so directly we are not able to create the LAN in this NSG tool, so we are making some prerequisite by using the NSG, then we are editing the TCL script. So then go to the link, duplex link, so from N3 to N4. So here we need to set the error model which is from N3 to N4. Then go to the agent. So go to, these are all some prerequisite to create the LAN. okay, so go to here UDP and from N1 we need to have this UDP, and go to the UDP means another side has to be null. So here from N7 this is null, and we need to connect from this to this, and even we need to have the application, that is CBR, that is for UDP 0. okay, so this is the prerequisite that has to be done in the NSG tool. Now go to parameters, and this is our third experiment, so out3 and out3.nam, and click done and click TCL. So this will generate the TCL script. Click save as and go to your folder. I'm using this ccn. okay, so here out3.tcl, then click save. Now our TCL file is saved. We can just go to open this TCL file. So in this, okay, so in this TCL file, so initially simulation parameter, then initialization, then it is opening the file to a NAM file, and 8 nodes it's already created. Then Okay, so 8 nodes are created. Then link definition, that means the link that we connected from. In this diagram we can see there is a link which is from N3 to N4, that is given here, N3 to N4. Okay, so then there is a node position. After this link definition, now we need to create the LAN. So for this we are using the command. Okay, so we need to create a section. What is that? So similar way we will create our own section here, that is creation of LAN. Okay, so creation of LAN, and again hash. So here for creating the LAN, dollar symbol ns make dash LAN. Okay, make LAN. So then we need to give the nodes, okay, in the double quotes. So n0, n1, n2 and n3. Okay, and then we need to specify the bandwidth, that is 100 MB, and even the time, that is 300 ms. Then LL, then quay bar, drop tail, and MAC bar 802.802_3. So this is the command we need to write to create. Now we created the one LAN. In the similar way we need to create another for N4, N5, N6 and N7. So here if we just write N0, it will not going to take, so we just need to add dollar symbol. Okay, yeah, this is now proper. 100 MB and 300 ms, LLQ bar dovetail, MAC 802_3. So in the similar way we need to create make LAN 4, 5, 6 and 7. So here 4, 5, 6 and 7. Okay, so now we created the LAN. So after that we need to create the error model. So from N3 to N4 we need to create the error model. So now we created the LAN. So after that there will be the agent definition. Okay, so after this okay, so here creation of the LAN. Okay, LAN is created now. So now we will create the error model. We will just create the error model here. Okay, so hash error model. So this also in the same way. This is simply I am writing like this. No need to write this, just write the command also enough. Error model, and we need to create the error model. So here to create the error model, set okay ERR set error new error model ORMODEL set error new error model. Then we need to use the dollar symbol ns and loss model Okay, loss model, just remember profit and loss to remember loss model. Okay, so dollar symbol ns loss model, it's a kind of loss model to create this error model here. So loss model, that has to be, okay, so error, then it has to between n3 and n4. So we need to specify n3 and n4. And another thing is we need to set the rate for the error. So error slash error set underscore set rate underscore. Okay, set rate underscore. So let's consider this as 0.1. Okay, so now we created the error model. So after that, in application definition, okay, so here what is the question? We have compare the throughput by changing error rate and data rate. So here to specify the data rate, so we need to add interval. Okay, so at what interval? So for that, after this rate underscore, we just need to add interval. Okay, so after the before this rate, okay, before this rate we just add cbr0 set interval, trvel set interval underscore, so 0.001. okay, simply I am setting this value. So here error rate is 0.1 and data rate is 0.001. okay, now we will save this. And okay, now this is saved. Go to the terminal and run it. So ns out3.tcl. if any error, then this will going to give that error. So there is no any error. So this is created now. You can see this. Okay, you can see these things. And even we can have this error model. Okay, let's place this before the creation of LAN. And let's check, can we place these commands anywhere in this code or not. So I'm just placing this error model after the link definition, and this creation of LAN, this one we just place after the nodes definition, and we will check. Okay, so just need to out3. so let's see here, there is no any difference here. So let's run this. Yeah, you can place these things anywhere. It is just to define the properties. So you can place these things after the nodes definition or after the links definition and thing. You can, but the thing is you need to have this creation of LAN. This is the separate thing. Okay, it is not generated by the script, that means not generated by the NSG tool. So first one, you need to have this creation of LAN, and then is the error model. So just remember, after the nodes definition, just write after these. Okay, so after these n7, n1, n0, n1, n2, n7, just create one LAN. Then after that link definition, After that, just create one error model. Okay, so this is the second thing, we need to write extra things. And then is the here, that is the interval, we need to set the interval. So this is the third one, we need to add interval underscore. This is the third thing we need to edit in the application definition, and these things we need to add. So now this is what the actual LAN looks like. So here this is just the LAN simulator. And now in the question, what they asked means compare the throughput by changing error rate and data rate. So throughput, we have one formula to find the throughput, that is throughput is equals to, you just need to remember P by T. Okay, so that is packet divided by time. Okay, so into, there is some value, that is 8 by 1024. Okay, you just need to remember this formula, 8 by 1024. So now to find this, we need to write again the AWK script. So here we have this out3.tr. So to extract the data from this one, we need to write the AWK script. So for that, just go to terminal and gedit. So which out 3.awk. So in this file, awk means always the begin, and body, that means our code, and okay, so end. So begin. So what the things we want? We want the packet and the time. These two are the variables. Okay, so here begin pkt equals to 0 and time equal to 0. I just declared the two variables and initialized to 0. Now in the body, okay, so if okay, so if $1 equal to R, okay, and so what we need to do now? So here we have this one, so N3 and N4, sent from N3 and received at N4. So that one we need to consider. So here, that is from N3 to N4. From means, so we need to just recall the syntax. First one is type, time, then from, then to, then packet type, packet size, then so yeah, so we can see the syntax once. What is the complete syntax? Okay, so packet type, packet size, there's the event or the type, I just wrote as a type event, and flags FID. Okay, so here this is, instead of type, we can call this as an event because it is like received, dropped, these are all the event. Okay, time from node packet, packet size, and flags, and FID. So here, that is from N3 to N4. Here we can see this is from N3 to N4. So here and dollar symbol from means 3 equal to from which node? It is node N3. So here this has to be 3 and dollar symbol N4. Okay, not N4, dollar symbol 4, that is 2, that is 4. So node 4 and 4. Okay, so 3 and the 4. Then okay, so then we should not consider the ACK. That's why we are considering the packet type. So and packet type means 5. Dollar symbol 5 equal to. So what is the packet type? It is CBR. Okay, so since we use the UDP, we just need to have the CBR. Okay, so this one is actually not necessary because here we can see in the okay, so I'm just going to open that tr file. So here you can see there is no any ACK, therefore all these are CBR only. So all these are CBR only, there is no any ACK because here now in this LAN we are not dealing with the ACK. So all are CBR only, that's why this is not necessary. Okay, even if we write also there is no any worries. So only this much is enough. If this is the case, then what it has to do? So we need the packet and we need the time. So packet is equal to, so we have the packet size, right? That we just need to add. Packet plus packet size means this one, that is this 1 2 3 4 5 and 6. So here dollar symbol 6. Okay, so that means we need to find the total number of packets and time. Okay, so time is equals to, time means it is the total time executed. So you can have this here, or even you can have the outside this if condition, because just it is the last time. Okay, so here we can see in this we just need to consider the this time. Okay, so this last time, that's why here I'm just going to print this. That's why I'm using here time means dollar symbol 2, and in this loop, that means this will going to check every line. So in this only we are going to print f packet and time. We just print the packet and the time. Okay, so packet percentage f and okay, so slash t and time percentage f slash n, then here pkt comma time. We are just going to print these things, and at the end what we need to write? Okay, so this is our block. From here the if started, this is our body, this is our body, and in the end block we need to find the throughput. So print f throughput throughput. Okay, so this has to be inside the quotes, throughput /n. Okay, so here throughput formula is packet, so pkt by, okay, so here we need to have this %f, packet divided by time, so we need to multiply this with *8 divided by 1024. So this is the simple AWK script. Just save this. Now let's check if we have any errors. Then this will going to give the error here. So AWK script control. Oh, I'm just saved this and I'm closing this. And now, so AWK, what's our script name? Out. Okay, this is the file /f out 3.awk, and on which file? Out 3.tr file, and this has to write this to out 3.txt. Click enter. So okay, so division by 0 attempted, something it gives the warning. Okay, so the file is created. Let's check the output. No, there is no output because it encounters with the division by 0. So how to solve this? Okay, so go to the TCL script. Okay, in the TCL, okay, in the TCL script everything seems fine. Go to the AWK. It's that out 3.awk. Then here packet equals to 0 pkt plus 6, and this is $1 equal to received, and yeah, this is okay. So here we wrote n4. We should not write n4. I told it has to be 4. That's why it is not encountered with this if, so these two remains 0. That's why we got that error. So be careful, don't write this as node 4 and 4, just write as a 4, then control S. So now let's rerun the script again. So now there is no any error. So now if we open the out3.txt, so this is just showing the packet and the time, and at the last it displays that throughput is 324.249231. okay, so this has to be in Mbps, that we can simply wrote in this AWK script %f. okay, so here Mbps. So now our task is to, okay, so we have these formula, so changing the error rate and data rate. Okay, so error rate and data rate. Okay, so we follow one table, just some values we need to take. So I'm just going to consider, okay, we will consider this as, okay, error rate. So that is we consider the three values 0.1 and data rate 0.001 and 0.3 and here 0.01 and 0.5, 0.1. Okay, so this one we will consider, and we will write its throughput. We're finding the throughput. Okay, throughput we just need to find. So now for 0.1 and 0.001, we got the throughput as 324. This is our throughput that we just need to put it here. That is in Mbps. Okay, so Mbps. Then 0.3 and 0.1. So just go to the TCL script, set the error rate, that is in the error model. So here set this as a 0.3. Okay, just go to the error model, and here 0.3, and here 0.01, that is change the interval. Save the script and run nsout3.tcl. Then simply close this, then again run the awk file, and now here we are going to have the 261.69 Mbps that we just need to note down here. Okay, and another thing is 0.5. Again go to the TCL script, make this as 0.1, that is the data rate, and make the error rate as 0.5, and save this and rerun the ns. Close the ns. It generated the tr file. Now awk/f-out3.awk and our tr file, and that is written to the out3.txt. So here we have now different throughput value. Yes, we just analyzed the compare the throughput by changing the error rate and the data rate. So the throughput will be more when we have the data rate as where data rate and the error rates are less. Okay, when error rate is more, the throughput will be less. Okay, so this is what the conclusion we can make. I hope you understood this. Thank you.